Okay, today we're going to do 8.6 solving rational equations. So we've worked with a lot of rational expressions so far. So an equation will have our equal sign, we'll be solving for our variable, and we're going to have at least one rational expression within those equations. To solve, what we will do is we will clear the denominators by multiplying by the least common denominator of all rational expressions in the equation. Okay. Then we'll jump into some examples. So the first one, 1 divided by x plus 2/3 equals 1/6. So I'm solving for x. X is in my denominator, so it's hard to get x by itself for our strategies of solving that we've learned from middle school. So it's not going to be helpful to leave x in the denominator. It also makes these problems harder if we have fractions. Many of you don't like fractions for some reason. Okay, so I'm going to try to find that least common multiple of every denominator. So my first denominator has an x, so that will need to be the common denominator. The next one has a 3 and a 6. So between 3 and 6, the least common multiple would be 6. Okay, so I'm going to multiply this equation by 6x to clear my denominators. Right, when I do that, I'm not multiplying my denominators by 6x, because when I multiply by 6x, that would be 6x over 1. And so I am only multiplying the tops by 6x. So if I rewrite this, that would be 6x over x doesn't change in the bottom, plus 6x times 2 would be 12x, and that 3 does not change, equals my 6x times my 1, and then divided by 6. Okay, so I just created a little bit bigger for numerators, but what's going to happen is I can divide the denominator out with the top in every single fraction. So this would give me 6. 12 divided by 3 would be 4, and it has the x. 6 divided by 6, so I'd just be left with x. Okay, if I could not divide the denominator into the top, then I did not have the correct least common multiple, or I multiplied wrong. Okay, now I can go ahead and try to get all my x's together on one side. Then divide by -3, and x would equal -2. Okay, as always, especially if you're taking a quiz or a test, we are not getting that immediate feedback like Math Excel would give you. Make sure you're double checking, plugging in, and making sure that that is correct. Whether you're just typing it into your calculator, double check, that's fine. Make sure if you're using fractions, you put some parentheses around them, and that should work out for you. Let's try another one. As always, we'll make it harder, the next one. So I have 4 over x plus 2 equals 5 over 2x plus 3. Okay, I have x's in both of my denominators. I want to make sure, I don't know what I was trying to say. I want to make sure I find that least common multiple so that I can multiply by it on both sides of this equation so I can eliminate or clear out my denominators. All right, I also am trying to solve for x and it's in the bottom, so I'm not going to be able to work with that until it is not in the bottom. So X plus 2, I can't factor that anymore, so that's going to be a separate factor itself. 2x plus 3, there's nothing I can factor out. There's no x squared. I can't factor that either, so that is also considered a separate factor itself. So this would be my least common multiple, okay? We've been talking about adding and subtracting fractions recently, so I'll have students that will get this mixed up because you're finding least common multiples, but I'm doing different things with them. I don't need to find a common denominator. I need to get rid of my denominators. So I'm multiplying this whole equation by x plus 2 and 2x plus 3. I'm allowed to multiply both sides to get rid of denominators because it's an equation. I have something to balance out on both sides. Yesterday, there were no equations. It was only adding and subtracting, just putting them together. Okay, so that's the big difference. We'll talk about that over the next couple days and compare them. So hopefully you're not getting them mixed up. But on top, I'll have 4 times x plus 2 and 2x plus 3. Remember, this is over 1, so I'm not changing the current denominator of x plus 2. And then equals 5 times x plus 2 and 2x plus 3. And I'm not changing that current denominator of 2x plus 3. So I multiplied by x plus 2, so I could get rid of that x plus 2. I had to multiply by 2x plus 3, so I could get rid of that 2x plus 3. I had to do it to both sides, otherwise I was not going to be able to balance that equation. So now I have 4 times 2x plus 3 equals 5 times x plus 2. Distribute, so 8x plus 12 equals 5x plus 10. Get my x's on one side. So 3x plus 12 would equal 10. Subtract 12 from both sides. 3x equals negative 2. Divide by 3. So x is a negative 2/3. Something you do need to double check. We've been talking a lot about restrictions on our variables, so you got to make sure that this answer is not one of my restrictions. That's one of the reasons why I've been saying x cannot equal this. When we get to equations, we need to pay attention to that. So x could not equal negative 2. We didn't get negative 2, so that's fine. And here, if I subtract 3 over and divide by 2, x cannot equal negative 3 over 2. So we're okay with a negative 2 over 3. Okay. Let's try another one. So I have x minus 1 over x squared plus 3x plus 2 plus 2x over x plus 2 equals x minus 1 over x plus 1. So we kind of get harder as we go. Okay. I want to find that least common multiple. Because I want to solve this equation, there's a lot of variables going on. So I got to make sure I get rid of everything out of the denominator, and then I can work with just solving an equation after that. So if I factor this into x plus 2 times x plus 1, I don't want that form. I want the factored form. I can't factor or simplify those in any way. So when I'm looking at that least common multiple or common denominator, it would be x plus 2 and x plus 1. So that's what I got in that first denominator, and that covers this and this. Okay, so if I multiply by x plus 2 and x plus 1, I will be able to get rid of that, that, and that. So I'm taking everything times x plus 2 and x plus 1. The denominators are only being multiplied by 1, so they are not going to change. So starting with the first fraction, I have x minus 1 over x plus 2 and x plus 1. That's the original fraction. What am I multiplying by now? I'm multiplying by x plus 2 and x plus 1. My next fraction is the 2x over x plus 2. So I'm multiplying that by the x plus 2 and the x plus 1. then it is equal to x minus 1 over x plus 1. And I'm multiplying that by x plus 2 and x plus 1. So what I have in blue is the original problem. What I have in green is what I'm multiplying every single term in my equation by. Okay, I don't want to truly multiply it out. I did that so I could eliminate every denominator that I have. And now I'm left with x minus 1. I can eliminate those x plus 2's, and then I'm left with 2x times x plus 1. I can eliminate these x plus 1's, so I'm left with x minus 1 times x plus 2. Okay, from here I've eliminated every denominator, and now I'm just solving an equation. We've solved equations like these before. Let's distribute. Let's get our like terms together. So I've got x minus 1 plus 2x squared plus 2x equals x squared plus 2x minus x and minus 2. I'm going to put some more like terms together. I can combine x and 2x. So I've got 2x squared plus 3x. And then there's this minus 1 equals x squared. 2x minus x would be 1x. So I've got x squareds and x's on both sides. We're solving this quadratic equation. I need to have it equal to 0 on one side. So I'm going to go ahead and move everything to the left. So I'll have a single x squared. I need to take x away from the 3x, so that would give me 2x. I need to add 2 to the 1, so that would give me 1. From here, I'm either factoring or using the quadratic formula. There is one problem. If I recall, you will have to use the quadratic formula for your homework. Okay, but this one is factorable. So x plus 1 times x plus 1 would multiply to x squared plus 2x plus 1. So x plus 1 equals 0. There'd only be one solution here since your factors are the same. Now, before you go about circling that answer, let's talk about the restrictions on this problem. X could never equal -2, and x could never equal -1. But what did we get? We got x to be -1. That can't happen, so there is no solution to this problem. I can hear the groans from the video when I teach this problem in class, and I say we go through all that work and there was no answer. Correct. That's possible. So there will be a no solution selection in your homework. You can select every time if you want. There's about one problem where that happens. So it's not going to happen often. Okay. But it can happen. So make sure you're checking those restrictions. All right. I want to take a look at a couple word problems that you will see, and then we'll be done with our lesson. There's only one type of word problem we're going to look at, and that will be involving work rates. So solving work rate problems. So as in the past, whenever we've had some application problems, typically MathXL doesn't have a lot of them. We've thrown in a few, but be expected on your paper test that you will for sure have to set one up yourself and write it out as work. All right, so a carpenter can build a desk in 6 hours. Another carpenter can build the same desk in 8 hours. How long will it take the carpenters working together to build one desk? It will be a similar type of problem every time. It's going to have either two people or two objects that are performing some kind of task, and it's going to take an amount of time for one separately, the other separately, and the two of them together. Okay, so there's going to be a common setup here, and it has to do with as a rate. So your little hint or your common setup every time, well, we have that one desk, and then this would be the hours that it would take one of the carpenters. And we need to add it together with the other carpenter who puts that one desk together. And then we're trying to find out if they're just putting one desk, how long would it take them together? Okay, so I have one desk. The first carpenter took 6 hours. I have one desk. The second carpenter took 8. And now I usually have students who want to put a 2 on top. It is just a 1 because it's still one desk. If they work together at their same rates of 6 hours and 8 hours, working together should be faster, but we don't know how long that will take. So here's the setup. So on a test question, I would give you points for the setup and then points for solving and your answer. All right, we need to use that least common multiple. So I'll need an x. The least common multiple between 6 and 8 would be 24. You're welcome to use 48. Some of you are just going to multiply 6 and 8. That's totally fine when we're working with solving. It's not going to make it any different. If you put too many variables, so if you use x squared or something like that, you're going to create a lot more problems for yourself. But if the number is just a little bit bigger, not a big deal. So I'll multiply everything by 24x. What's nice about this is there's all ones on top. So really it's just 24x over 6, 24x over 8, and 24x over x. So when I go to divide, I will get 4x plus 3x. My x's would divide equals 24. 7x equals 24. Divide by 7. For something like this, I would just double check MathXL. It might ask for your answer as a fraction. So 24/7 of an hour. It might say you can turn it into round to the nearest 2 decimal places or hundredths. All right, so that's approximately 3.43 hours. I'm not sure what it's going to ask for. Typically, in MathXL fashion, it will vary by problem. Okay, so make sure you pay attention to what it wants. But both of these would be acceptable for a test on paper. Okay. I'm going to set up one more word problem for you. If you feel you need to see another very similar, so one pipe can fill a pool 1.25 times faster than a second pipe. When both pipes are opened, they fill the pool in 5 hours. Here's our question, how long would it take if only the slower pipe is used? So it will be a pretty similar setup. I'm filling up one pool over the amount of hours it would take one of those pipes. I'm filling up one pool over the amount of hours it would take the other pipe. And I'm filling up one pool, and the two of them open together is 5 hours. Okay, so we have 1 over the amount of hours of one situation plus 1 over the hours of the other situation equals 1 over the hours together. And that is the same setup every time. Okay, sometimes you're given the together, sometimes you're given what they do separately. This one, what's a little bit different is we don't know either of them. So I don't know this one, and the other is 1.25 times faster. Okay. So here, we're going to go ahead and multiply by the least common multiple of my denominators. So some students get thrown off because 1.25 isn't a whole number. So they kind of get confused at what I multiply by. 1.25 does go into 5 evenly, so some students will come up with 5x. Others, I tell them, we'll just take 5 times 1.25, and you have 6.25x, and just multiply by that. Whatever's going to be easier. What we want to do is we want to get rid of the x, the 1.25x, and the 5. So whatever you need to multiply by to do that, you do that. So on top, everything on top is just being multiplied by 5x, and I already have a 1, so that's 5x over x plus 5x over 1.25x equals 5x over 5. So I will go ahead and eliminate my x's, so I'll have 5 plus eliminate my x's, and 5 divided by 1.25 would be 4. 5 divided by 5 would be x. Nice simple equation when we're done. So x would be 9. So make sure you pay attention to as well if they're asking you for both pipes, if they're asking you for one pipe, and which pipe they're asking for. So here's x. So that's 9. The other one I need to take 1.25 times 9 would be 11.25. So now this always throws students off a little bit. It's asking for the slower pipe. So the slower pipe would take more time. So 11.25 hours would be my answer, because 9 hours would be faster than the other pipe. And they kind of get confused because yes, we did the 1.25 times that, thinking that that was the faster one. That's going to kind of be backwards of what you're thinking there. All right, that is it for our 8.6 lesson. Let me know if you need help with your homework.